welcome. Okay, so a bunch of stuff has happened in the last 2 weeks, basically because we've had a lot more people involved, primarily driven by our participation in Outreachy, which is so Outreachy is kind of like Google Summer of Code, is the one sentence summary of it, but it's doing paid 3-month internships focused on supporting diversity in open source. So through that, we've got about 100 people in our Outreachy Slack channel with they're all very junior, looking to do an internship with us. Out of that 100 people, about 16 of them have managed to get all the way through the make a really trivial pull request into the Parsl code base. So if you follow Parsl PRs, you may have seen a lot of people making small increments to the flake8 maximum line length setting, and then reducing, fixing the errors that come up. That's the intro PR that we've been having people do. 16 people have managed to actually get that done all the way to having it merged. 8 people have managed to have some other kind of PR that's involved a bit more thinking or paying attention to issues or something else going on. And then the end goal, like I was just saying to Dan, is we've got 2 projects which we can take interns for. Sophie's leading a documentation one, and Yado and me have quite a fun high throughput executor worker assignment project. So we can take a maximum of 2 people, basically 1 for each. And that's the end goal of this funnel, and we get to decide that during April. So we've had people, sort of quasi-mentors on that, me, Sophie, Yadu, Kevin, Logan's been a bit involved, Andrew's been a little bit involved, and that's stirred up quite a lot of other, I say problems on this slide, but I don't really mean problems in a bad way. It's stirred up development, more things at once, because there's been more people involved. And it's also pushed us over, as far as GitHub counts, it's pushed us over 100 contributors, which is a nice symbolic milestone. I think Kyle wants to award a medal or something, some kind of prize. Okay, so I'll just go through briefly or not briefly, through about 10 different things that have happened in the last 2 weeks since the last call. So scaling wise, at the same time, Yadu's been working on attaching the scaling code to Globus Compute a bit more and unforking that code a bit more. I've been working on some stuff with Ghent University to do scale down a bit better. And both of us have hit similar kind of problems, that the scaling code sort of has multiple data structures through the stack, that they all contain their own different view of what blocks and job status looks like. And they're all updated at different times by different entities with different pieces of partial information. So some providers know which jobs they've launched, some providers know which jobs they've queried the status for, not necessarily both. The block provider executor knows which blocks it's launched, and then it also records failed submissions. Submission, how do I spell submission? Yeah. HTEX munges the status again if a block has not connected. So that's that's something Yadi did recently, so that we can look for blocks where the batch job starts running, but then the process worker pool isn't starting, perhaps because the environment's wrong or something like that. And then the job status poller has its own status table that is those with even more munging going on when scale up or down happens. And it makes it really hard to get a coherent picture of everything that's going on. It's really hard to reason about. 3 people have looked at PR 3247 and basically approved it, and it's actually completely broken, for example, because for reasons. So you end up with stuff like, with that PR, it will spend 60 seconds scaling up and up and up and up and up. And then after 60 seconds, it's realized it's got enough blocks and stopped scaling up. So the general direction for that, I guess, is less abstraction and trying to push more stuff centrally into the block provider executor, which is something that's been going on the last few years. I think that's the right way to be going. Get rid of some of the abstractions where we're not making use of the abstractions. All right, next topic. Tidying standard out, standard error. Something Sander asked for and is paying for is when you have lots of jobs and you redirect your standard out and standard error, you end up with lots of those files, and please put them into a zip file. So one of the ways I want to try this is tidying up some features which are almost there but not quite. So we've got file staging provider that stages file staging, can stage files out somewhere to some destination, right? And so I prototyped a provider that treats a zip file as a destination. We don't have support for treating standard out and standard error files as files in the sense of file staging. So I did a bit of code to make those be treated like files for the staging system. And then I got a few questions about how do we make sure that that staging has happened by the time Parsl exits and what happens on failed tasks. So that seems like a good opportunity to consolidate our file staging code a little bit.
So there's a question from Logan about how is Sander paying for this?
In euros.
Okay, like contracting
money.
you?
Yeah, contracting.
Okay. Yeah, I was just wondering what
so
the
basically it's just another subcontract relationship, which is the same way that it works for Argonne and the same way it works for University of Chicago.
Okay. Cool.
It's another one of those.
Yeah. I didn't realize we had, well, a formal like cat changing hands relationship. That's great.
Yeah. And like it's not a lot, but it's that's why yeah.
Sorry. I was going to say, it also makes me wonder about if we should be trying to, once we get NumFocus going, to be using that for this, because that was one of the things we said we would do at some point, would be have a way that people could kind of bid for small tasks.
Yeah.
Sorry, I don't mean to take something away from you, Ben. I'm just trying to think.
Yeah. Right. I mean, it's interesting to, I mean, it's good for us to be in this position of like, oh, we've got a structure in place to be able to do that, right? Rather than just people gnashing their teeth and getting frustrated.
Yeah, at least once Chicago signs off. But yeah.
Okay. Slide 5. Beep. This is pretty horrible. So Python 3.12. So broader context. A load of stuff in Python has traditionally been quite not very thread safe. And that's caused a lot of weird hangs in Parsl in the past. One thing Python 3.12, which came out relatively recently, has done is been a lot more aggressive about not letting you do broken things. So basically that means with Python 3.12, we can't call our cleanup code automatically on process exit anymore. Which a lot of for users where they just write a workflow script and then let it fall off the end when they're done. That's the model of how their stuff got cleaned up. So killing other processes, shutting down batch jobs, things like that. From Python 3.12 onwards, we can't do that anymore. So one of the Outreachy people swapped that out for a warning that says, well, we're not going to do this anymore. This is why you're seeing stuff left behind. And that's going to generate support load. It already did. Taskvine in their own internal testing noticed the second order effect that their code just hangs if you didn't clean it up rather than exiting. So I expect to see a few bits of things like that. A couple of other Outreachy people are working on trying to do a context manager style implementation. So you'd be able to do with Parsl, like in that code sample. And then we'll get the implicit cleanup at the end of the with block. rather than at the end of the process. That's a pretty standard Python idiom for working with things that allocate resources and need cleaning up. So things like locks, like files, stuff like that. And for people who are using sort of frameworks where those frameworks already do a cleanup call, that's not a problem. But it feels generally crappy, but here we are.
So Ben, a question from Kevin as well, because I don't think you're seeing chat. Kevin, do you want to speak up? Or not?
Do you want
Kevin
to
is
ask?
muted still.
Oh, okay.
Okay, I don't think he's.
So the question was, is that only not implemented come Python 3.12, or is it now removed wholesale?
It's now removed wholesale.
Okay.
Yeah.
Thank you.
Flux. So another Outreachy driven thing. We've got a bunch of Flux related components from the Flux team. So they contributed an executor. They contributed some tests which are not run in our CI. And they also showed a GitHub's action script that can run arbitrary stuff in a Flux environment in a Flux container. So the Outreachy task was, please stick all these pieces together. And as happens when you test code that wasn't tested before, you discover it's broken. So one test regularly hangs there in a way that I find very confusing. I'll write it up in an issue. Maybe Flux cares about that, or maybe they've abandoned their contribution. That's kind of the vibe I got before, but I don't really know. But I think we can merge the test anyway and benefit from testing that integration a bit better anyway. We already discovered, for example, that MPI HTEX work that both Yada and myself thought was completely unrelated to Flux managed to break the Flux executor for our single Parsl and Flux user. So this would stop stuff like that happening. And that's an interesting thing from a sort of test technology perspective as well, that it's kind of interesting to say, all right, this is hard to, it's a hassle to install this environment, but the Flux people did it already, so we don't need to think about it. So rather than trying to build this one container environment that our main test runs in, which has got everything installed in it. So we, for example, install work queue and task line and an SSH server and stuff like that. It's an interesting approach, I think, to look at running component-specific tests in a component-related container. All right, next topic. 3 left, I think. MPI. Andrew asked in the chat, is anything happening with MPI? And no one replied to him. I know that I don't have time to work on MPI particularly.
So I can speak about this though.
Yeah.
So there was a bit of a delay on this, and there was a bunch of conversation that happened over the weekend. Oh, shoot, I'm looking at the wrong thing. Yeah, so I think the short of it is basically that Andrew rightly pointed out that there is a bunch of weirdness coming from the fact that we bolted on a bunch of MPI behavior into the high throughput executor, which is not really designed for that sort of behavior. For example, the assumptions about running workers across many nodes in the job does not apply to MPI mode, where all the workers will run on one node. The mechanisms to automatically detect and launch the right number of workers per core doesn't make any sense, because with MPI, you just want to run a specific set of workers.
Right.
Like a bunch of these things just feel like a bolt-ons to the high throughput executor. So I agree with that assessment of the interface being clunky. So what I've done is I've started on like a separate branch where I've got an MPI executor, which is basically inheriting just the high throughput executor, but with a cleaner interface with regards to everything MPI related and stuff that you would have to change.
Yeah.
It's a very thin layer. So I've got stuff in testing. So I'll probably have something by the end of the week to like show. But again, it's very limited in terms of functionality. It's just a very thin, like it's sugar semantics on top of what a high throughput executor with the MPI mode does for you.
Yeah.
Is it like a subclass of HTEX?
Yeah, it's just
Okay.
that. Yeah.
Excellent. And is this going to fit the use case of being able to call MPI as a subprocess from within a Python app?
Right. Yeah. So that's again, we've always had that use case in mind when designing this stuff. So in the case of the Python app, with a Parsl resource specification specifying how many ranks and whatever you need, nodes you need, you would basically have the Parsl MPI prefix available to you and all of the rank information available to you. And while Parsl would not do the launch of the MPI for you, you get to compose the prefix from inside your Python code and do with it as you please. So all of the Python app behavior where you expect the app to then call MPI should just work out of the box.
Okay, awesome. So we'll still get so what you're saying is we still get the Parsl launch, or I forgot the particular name of it.
Yeah, you basically get the Parsl, the prefixes for the launchers like made available to you.
Yeah.
That is basically there to like basically abstract over the case where you would want one Python app defined that would potentially run across a bunch of different machines if you were to pick and choose the configuration. So for example, you would have a Python app which would specify internally the string as Parsl MPI prefix and the quantum chemistry launch command. And what I would let you do again is you could say run it on Midway, and because it's using srun, because the srun launcher is specified, the MPI prefix is going to be for srun, versus if you were to point it at Polaris, the launcher prefix is going to be MPI exec. So you wouldn't have to specify different variations of the same Python app for different machines. That's the big benefit. If you were to choose, if you were to choose to use the launch prefix, right? But it gives you something already like a canned solution for that machine agnosticness aspect.
Right, that makes sense. And mine, so Ben, I don't know if you had more to talk about, but I've got a few other kind of follow-on questions with MPI, if we can do that here.
Yeah, we can.
Where did we come down on being able to specify environmental variables as part of these MPI tasks?
This is me, and you and me talked about this, Logan, and I said this is orthogonal to MPI.
Yes.
Where we mostly came down on it.
All right, and who was the first name?
Me and you.
Oh, yeah, okay. Yeah, all right. I thought you said Yuli, and it's like, oh, new development.
Yeah.
But yeah, no, I think it's orthogonal. I was wondering whether there was some way to, when I decorate a task, if we've got this MPI task decorator, to be able to provide environment variables that it should use, considering that they might conflict with Parsl. So I remember like many moons ago, Yadu was having problems installing Parsl and an app in the same environment.
Yeah.
And I was wondering if we ever came down on providing a way of sidestepping such environment shenanigans. And it sounds like that hasn't, which is cool.
I mean, my users that I've supported just have set environment variables in their bash app command line, I think.
Oh, they do? Okay.
I think so.
Yeah, so so Logan, whatever issues that I had and reported, were basically addressed by exactly that pattern, where you have the Parsl worker launched in whatever environment, but then the application, because it's a bash app, I basically had a wrapper around it which just said unload everything and then load whatever environment I need for the MPI app to run, and that works just fine.
Okay, that makes sense. And that's like part of the bash command that you're issuing. It's
Exactly.
like this command is.
So the first thing I do is unload the environment, so none of the Parsl specific conda weirdness comes through, and then I just load up the environment that I need specifically.
Okay, that makes sense.
Yep.
Yeah. So that does make me wonder on how, if we're not handling, if there's a more clever way we can handle environment variables, because the whole notion of this Parsl prefix making your bash app machine agnostic falls apart when we start having to change your bash app to put in the right environment variables.
There's a few other places where that happens, like Parsl resource spec doesn't make sense. Is executor specific, right? So in environments where you're wanting to switch between an HTEX setup and a work queue setup, then suddenly the format of those needs to change as well.
Okay. Yeah, that seems like
it's a sort of, where do you've got this product space of executors times apps, where do you put those annotations? And there isn't anywhere for those annotations at the moment.
All right, yeah.
Hacking it in yourself, but it's a thing, right? Like VDS, so Parsl version -2, the virtual data system, had a big table for this that was basically a 2-dimensional table. Where you said, when you run this app on this site, here's a parameter to use. It's quite unwieldy, but it's a thing. Like it. Yeah,
well, that's fascinating.
But I think it's interesting. We should stop. We shouldn't be calling it MPI. It's nothing to do with MPI. It's just happens to be your use case happens to also involve MPI, I think. But
that's fair.
But it is a thing, right? With DESC, we've done some stuff because users there do switch between the high throughput executor and taskvine, and those have different source specs.
Yeah, that makes sense. And so while we're riffing on MPI, a quick thought. Where do we envision this lookup table being stored? I'm so lucky that when I port my apps between different environments I use the same executor, so I'm missing one thing. The other thing is none of my environmental variables screw with Parsl. So I can put them in my application, what's it called? My worker init contains all of my environment variables that I set up that will be harvested later by the app I call.
Yeah.
Do you think we could provide a place, like a home for application-specific environment variables within the executor? So that someone, let's say, I'm thinking in Globus Compute world, who installs a executor on a remote system, when they're envisioning that their users may call a certain app, they could put in config variables for running that app on their system hidden within the executor definition. Do you feel like that could be, is that the kind of route forward you were picturing on this sort of?
Yeah, maybe. I mean, a lot of this can be done in user space, I think. Like your bash app is allowed to look up variables and things.
That's true. Yeah, and it could. I was just trying to figure out how much, if we're going for the goal of making the user has no changes in user space as they port between systems. Then I was thinking of hiding it in the executor, which still has some user domain. But, I don't use Globus Compute that much, and this is the Parsl call, so I don't know what relevance it has here.
No, I think it's a rich space for experimentation because it's primarily a user experience thing rather than a tech thing. I think. So then it has a different feel for how you evaluate it.
Yeah, I mean, like Ben and Logan, So I run into similar things, and what I always have is on every machine that I go to, I just have like a source setup Parsl environment.sh and a source setup compute environment.sh. And I just stick all the environment variables that I care about in those files, and I activate it as part of the worker in it. So whenever I have a worker on any machine, like the machine specific environment variables are just all set, which again is a poor man's, environment variable like setup. But again, I kind of see how that might be annoying for some users, especially in like compute land, because you now have to have either the worker in it, like specify all of this, which means it can get really big and clunky, or you dropping this file onto the machine means that you have to like log onto the machine.
Yeah, and then like config or spread multiple places,
Right.
reuse such that.
Yeah.
Well, this is not a Globus compute call, though.
Yeah,
So,
again, right.
Globus compute has its own different config system that has its own properties.
All right.
Yeah.
Yeah, it'd be fun to get a chance to go on this crusade.
Yeah. Cool. All right, I'll go through my last points. We finally got to implement a feature. I don't get to implement features very often because mostly I'm just fixing stuff. But I implemented some basic like worker draining. So one of the big problems with the HTEX pilot job is that jobs just, as far as HTEX is concerned, when a job runs out of wall time, it just ends. And there was nothing in there to say, well, these workers are about to die, don't run any work on them. So there's a really basic draining facility now where you can say, all right, don't send any tasks to this worker in the last, say, 5 minutes of its lifetime. And so whatever's running will continue running, but nothing new will get sent to that worker, and eventually it will run out of tasks, hopefully before it gets killed. So that is pretty good when the tasks are all about the same length. And then one of the possibilities for our Outreachy project is doing it more like WorkQ does, where your task has a required time as a resource specification. So we can say, all right, when there's 10 minutes left, only send short tasks to this worker. So hopefully that's something coming up on the scope of the next 6 months. But the basic draining is already merged, and it's a simple config option. You just set a time for how long this worker is expected to run for before it should start draining.
Sorry, just a question on that first one.
Yeah.
So what difference does it make in the end? And if you ran stuff on, you started running stuff on the nodes that are going to go away, and it doesn't fit. How is that actually a gain? How is what you're doing now better than that? Like, what do you save it?
You get one less failed task.
And then if there are no tasks which can run on them, they idle and die.
Yeah. Okay. Sorry, that's the part I wasn't thinking. Okay.
Yeah.
So two things, yeah.
So the big thing is avoiding sort of taking control of the end of the worker lifetime a little bit more, rather than it just being done to you. Yeah. And the second point, the more advanced style lets you
that one definitely
pile things a little bit better.
Yeah.
Rather than draining so fast. All right, DESC. I did a lot of stuff over the last year or two with David Adams somewhere in California. Now I'm just trying to merge a load of my 5 years of DESC divergence back into Parsl, which is this ongoing project. But all the easy stuff is done, so now it's only hard stuff. There's a lot of tests that show things are broken, so I need to fix the thing before I can put the test in. A lot of that's around monitoring and around exiting nicely, which is our ongoing awful project. A lot of fork versus threads re-architecting scope, maybe, which is blur. and some nice, I hope, monitoring work as well. And then the last thing is the Debian people, their binary reproducibility project put in one PR, and I worked in another PR with them. So their reproducibility project is about, if you start with the same source package and you build it, you should get a bitwise identical binary package, no matter who builds it and when they build it. And so there were a couple of tweaks they needed to do there to make that happen. They seemed happy that at least I was interested in that. Yeah. So that's all the stuff that's been happening in the last 2 weeks.